The night sky has a strange way of making us feel both infinite and impossibly small. When you look up, you see a canvas dotted with billions of stars, each one a potential sun for its own family of planets. And yet, for all this cosmic abundance, there is a deafening silence. No signals, no megastructures, no evidence of other civilizations, just an endless, almost uncomfortable quiet. This contradiction has haunted scientists for decades. If the universe is so vast and full of worlds, where is everybody? Enrico Fermi asked that same question in the 1950s, and it hit with the force of a philosophical earthquake. The more we learn about the universe, the more serious and chilling his question becomes. Modern astronomy has revealed that planets are not rare at all. Most stars have them. Many are in habitable zones. Some even show atmospheric compositions that could support life. And yet, for all our sensors, telescopes, and decades of listening, the cosmos remains mute. The silence itself has become a clue, and some of the explanations scientists are exploring today are as thrilling as they are unsettling. One of the most spine-tingling ideas is the concept of the universe as a dark forest. Imagine a dense, pitch-black wilderness at night. Every creature is hiding, listening, trying not to make a sound. You don't know what else is out there. You don't know its intentions. You don't know its technology. The only certainty? Revealing your position could be fatal. This metaphor suggests that advanced civilizations deliberately avoid sending signals or constructing visible megastructures. The safest strategy is to remain invisible. The moment you broadcast your presence, you expose yourself to unknown dangers. Some astrophysicists argue that if even one aggressive civilization exists, natural selection would favor silence everywhere else. The cosmos isn't quiet because nothing is out there. It's quiet because everything that survived learned not to scream into the dark. It's a haunting thought. Perhaps the reason we hear nothing is because all who made noise are gone. A second explanation is just as profound and far more existential. It's the idea of the Great Filter, some kind of universal barrier that prevents life from becoming advanced enough to communicate across the stars. This filter could be behind us, meaning we already passed the rare, almost impossible steps that most worlds never overcome. Perhaps the jump from simple cells to complex organisms is astronomically unlikely. Perhaps intelligence is an evolutionary fluke. Perhaps Earth is 1 in a trillion. If that's true, we are incredibly lucky. But the darker possibility is that the Great Filter lies ahead. Something may inevitably destroy technological civilizations before they can spread among the stars. It might be climate instability, nuclear conflict, AI runaway scenarios, biological disasters, or cosmic catastrophes we haven't yet discovered. Every silent world we observe could be a tomb, and the silence might be a warning. If all other civilizations reached a certain stage and then vanished, we may be heading toward the same fate without realizing it. The Great Filter is terrifying, not because we know what it is, but because we don't. There's also a gentler, almost philosophical hypothesis. The universe may not be silent at all. We might simply be quarantined. This is known informally as the cosmic zoo idea. In this scenario, advanced civilizations deliberately avoid contact with emerging ones, allowing them to evolve naturally. From their perspective, humanity could be like a species in a protected reserve. They watch, but they do not interfere. Not because they fear us, but because they respect the developmental process of young civilizations. Some researchers suggest this could explain the eerie consistency of cosmic silence. If there is a collective agreement among advanced beings not to disturb developing planets, then Earth would sit in a kind of cosmic observation bubble. Every attempt we make to reach out would be ignored until we reach a certain level of maturity or stability. It's a strangely comforting idea, but also a humbling one. The universe could be full, and we simply aren't ready to join the conversation. Another increasingly popular explanation is that we're looking in the wrong way entirely. Our entire search strategy has been shaped by human assumptions. We expect alien civilizations to use radio because we used radio. We expect them to emit waste heat because our machines do. But what if their technologies evolved in completely different directions? They might communicate with neutrinos, gravitational waves, dark matter modulation, quantum entanglement, or methods we haven't even imagined yet? What if their megastructures operate at wavelengths our instruments don't detect? What if their energy signatures blend into natural cosmic noise? Even our idea of physical form might be limiting. A sufficiently advanced civilization might transcend biology entirely, becoming digital, photonic, or integrated into stellar environments. Meanwhile, we continue scanning for radio signals like someone hoping to find Wi-Fi using a stone tablet. The silence might be an illusion created by our own technological infancy. And then, there is the final explanation, one that is both exhilarating and deeply sobering. Maybe the reason we find no one is because no one else exists yet. Maybe intelligent life is extraordinarily rare, not because the universe is hostile, but because it is still early. Stars like our sun are relatively young. Heavy elements required for complex chemistry only became abundant in the last few billion years. Conditions for life may only now be stabilizing on many planets. It's possible that humanity is one of the first sparks of intelligence to emerge in the Milky Way. Perhaps the first. If that's true, the silence isn't an absence. It's a beginning, a blank page waiting to be written. But being first comes with a kind of cosmic responsibility. If intelligence is rare, then we may carry the burden of representing the entire concept of consciousness in the galaxy. Our survival wouldn't just matter to us, it would matter to the universe itself. We might be the pioneers, the trailblazers, the creatures whose footsteps echo across billions of years and worlds. The idea is awe-inspiring and terrifying. The paradox of Fermi isn't just a puzzle, it's a reflection of our deepest fears, hopes, and limitations. Each possible solution says something profound about what it means to be human. The dark forest warns us about the cost of visibility. The great filter confronts us with our fragility. The cosmic zoo reminds us we may not be as special as we think. The wrong search hypothesis exposes our technological naivety. And the "we are first" idea shows both the magnitude and loneliness of our cosmic role. What makes the paradox so haunting is that we are, for the first time in history, in a position to find the answer. The James Webb Space Telescope is analyzing the atmospheres of distant planets. Radio arrays are listening deeper and wider than ever before. Gaia is mapping the Milky Way with unimaginable precision. Fast radio burst detectors are picking up mysterious cosmic events. And AI is beginning to filter through data too complex for humans to analyze alone. We are entering an era where the question, "Where is everyone?" may transition from philosophy to discovery. And yet, perhaps the most striking truth is this: the universe might not be silent at all. It might simply be waiting. Waiting for us to survive long enough. Waiting for us to grow wise enough. Waiting for us to listen in new ways. Or waiting for the moment when we become ready to answer the question ourselves. Whatever the truth is, the silence of the cosmos is not empty. It is filled with possibility. It is filled with stories we haven't heard yet. And in that silence, humanity stands at the edge of something vast, mysterious, and beautiful, on the brink of discovering what other eyes, if any, have ever looked out upon the stars.